Good morning, guys. This is part two of my motor control circuits, and I would like to show you several things here today. So in order to try to keep it from being just too long and confusing, I'll break this up into maybe even another part. This is part two. We may have a part three, but for now, let's cover some of the new features that I have. If you remember from part one, I told you that I had an optional method for the rotational limit stops, and that's what this is, these two switches. And I've also added speed control, and I have a new switch for the Autoscan module. So with that, let's just see how this works out. There's speed control. Obviously, I'm operating this with my foot pedal. So you can see it just go down to a crawl and then come on up to wherever you need to be. The next thing I have is, let's take a look at this new switch. This guy's is pretty neat. You can either operate it with a key fob, or you have a puck that has magnets on the back, and you can pop it onto any metal surface. And metal surfaces are sometimes hard to come by on a bass boat. So we have a sticky back metal disc that you can place wherever it's convenient for you, and you can just turn this Autoscan module on with that as well. And this will show you an advantage of having speed control now, because you have a fixed 5-second between each reversing, and it's not fixed. You can adjust it on the on the timer, but it's not an easy thing to do. So we're just by being able to slow it down, we can change the scan width that we have. Okay. So with that, that's sort of an introduction. I'm going to pause for a minute and get some things straightened up, and then we're going to talk about polarity. Thanks. Okay, let's talk about polarity. Before we do that, here's why. I told you before that I have an alternate switch arrangement for the rotational limit stops, and here they are. There's two normally closed switches, one on either side. Switch 1 here, switch 2 here, and each one of them has a diode jumper. This thing only works correctly if you get the polarity right. And the whole basis for what we're doing here goes back to an industry standard, which says that if you put a positive voltage on a permanent magnet DC motor, if you put that on the red wire, that it's going to rotate in a clockwise direction. Now, clockwise viewed from the top now, not the bottom. And that will cause that clockwise rotation, and then the current will flow, obviously come back out the ground wire through the black wire and go back to ground. Now what I've done is I put these two normally closed switches in series on the ground side so that we can break that current flow and be able to stop that rotation. If you look at this, if I can get close enough, you will see that this is switch 1 because it stops the rotation on the clockwise side, and the ground wire comes into switch 1 on the normally closed contact, and it goes out on the common the common then jumpers over to switch 2, and it comes out on the normally closed contact side, and it goes from there. You will also notice that I have 2 diodes, each one facing the normally closed contact. So they're facing the band on there, which designates the anode. They're both facing away from each other in the circuit. So with that in mind, I think it's probably better that I move up at this point and work and explain this based on the schematics. So hold on just a minute. Okay, now let's look at that on the schematic. And this represents, on our controller, this red wire representing the positive cable is hooked to M1 on here. And the current flow then goes through M1, through the motor, out through the motor, through the ground side, and on over to ground through those 2 switches. Now, as it's rotating clockwise and it hits this, obviously it's going to break that. And the positive current, the positive voltage will not allow current to flow through the diode. This symbol represents the anode on this side, and the current cannot flow from this side. So when we break that, it stops the motor rotation. So at that point, we hit the green button, and that will reverse this polarity. And now we have power coming through this side, through that closed switch. It comes to here. This guy's, momentarily anyway, is still open. So it can flow, current can flow from this side through the diode, and it comes on over and completes the circuit and flows on through. And the motor, when the motor rotates just a small amount, it's going to close this switch, and then you'll have current flow completed back through that circuit. So you just kind of jumpered it out in that situation. Now this is going to continue to rotate in a clockwise direction until it makes this switch or breaks this switch. And so what you have to do is reverse it again, and you're going to have positive voltage here. The current's going to come through here. Now, the current can flow through this diode because the anode's facing away from it again. So you'll have current flow through here, and it goes on and makes ground. Very quickly, this closes back, and now you have 2 closed switches, and you can just rotate back and forth. So that's the whole deal. It's pretty simple. You just have to be aware of the polarity. And the other thing to be aware of is that switch 1 has to be, let's just say it has to be closest to the motor or closest to the direction of the current flow. I'm not sure quite how to say that, but I think you get the idea. So this is switch 1. So when it's going in a rotation, and when it's going in a, what am I trying to say? When it's going in a clockwise direction, and this is the guy you need to stop it. And the other thing is just to be aware that the band on your diode always faces out. So that's about all there is to it. So with that, I'm going to pause again and come back, and we'll talk a little bit more about how to the changes that I've made to the Autoscan. Thank you. While we're talking about polarity, I want to take the opportunity to show you a couple of things on the Autoscan module. And wiring here is pretty straightforward. You just got the battery voltage coming into the variable voltage controller, providing power to the switch, which in turn provides power to the board whenever the switch is actuated. Now here's the thing that I want where you could get crossed up. Whenever you provide power to the board, relay 1, which is this guy, will close, and that provides power across the normally open side, normally open contact on this relay, which in this turn is connected to K1. And alternately, relay 2, the normally open contact, goes to K2. And of course, the common on both relays go to the common ground of the circuit. Now, something I want to bring your attention to is that this will help to keep you organized. One of the things I do is I keep the wire colors the same as it is on the chart here, just to make it easier for me to keep things hooked up in the right place. And the other thing you'll notice about this is that, remember when we talked about motor 1, M1 was positive? Here, K1 is positive, and over here on the switches, S1 is positive. So they're very consistent, both with wire colors and numbering system, to help you keep track of where you are. So that's just about it. I hope I've been able to cover this thing in a way that's not too confusing. Honestly, it's been a real challenge to try to figure out how to do this. Of course, when you're not very good at something, it's always a challenge. But either way, I hope this is helpful to you, and I hope that in the future I'll be able to post something else that will be of benefit. Thank you.